Okay, we have retained another integral. This one's from the UK integration bee, sample number 20. We have the integral of e to the 2x plus e to the 3x over e to the x plus e to the minus x dx. Okay, to get started with this, I'm just noticing we pretty much have e to the x everywhere, and we can look at this, like for e to the 2x, we can look at that as e to the x squared or e to the x cubed. And I don't think I have an obvious way to factor this, so I think what I want to do is let's just start with a u substitution to try to simplify all this, turn it into a rational expression. So if I just do u equal to e to the x, take a derivative, so for du we're going to have just e to the x dx. Then let's solve for a value for dx, so we'll have dx divided by e to the x, we'll have this as du over e to the x, but e to the x is just u, so for my dx we can write this as du over u. Then let's just go ahead and substitute. So this here is going to become u squared. Then we'll have plus u cubed. Here we'll have u plus 1 over u. And then our dx is this thing, so we'll have this as du over u. But then let's just multiply in the u here. So then what's going to happen when we rewrite? And so multiplying this in, we'll just leave our numerator for now. And then this is going to become u squared plus 1. And then from here, we could do polynomial long division on it, but that's kind of boring, so I'm going to avoid that. What I want to do is kind of create the numerator where we can get some simplification and get some integrals that are easier to deal with. One thing I can do right here, if I add a u, then what's going to happen is when we factor a u out of this, this is going to be u times u squared plus 1. So that allows me to create something where we can cancel, but I don't want to change it, so we subtract off a u. So then we'll take this and we'll create it as two integrals. First, with this first one, we're going to have this u cubed plus u, but I'll break it out like this as u times u squared plus 1. And then here for the second one, we're just going to have this u squared minus u. But I think I'm going to do the same kind of thing again, because what I can do now is if I create a plus 1 here, then we can get more cancellation. Don't want to change it, so let's subtract off a 1 here. So we can cancel u squared plus 1 here. Then for this one, I can get my cancellation if I separate this off, but I need to take this piece here and separate this out into another integral. And actually what I'm going to do is I'm going to take each of these and separate and create two more integrals. So then now we can cancel this right here, so this integral becomes 1. And we basically have a bunch of easy integrals now, so let's see if we can kind of put it together. Integrating here, integral of u, that's just going to be u squared over 2. Here, integral of 1 is just going to be u. Here, if I just multiply in by a 2, and multiply in by a half, what happens then is we have the exact derivative of the denominator in the numerator. So we can just do this and get our natural log integral. So what's going to happen here, this is going to become minus 1/2 natural log absolute value, even though we don't really need it, of just the denominator u squared plus 1. And then here, this is just arctan. So here we're going to have just arctan of u. But now all we need to do is take this right here, back substitute, and then we can finish it off. Okay, now for the back substitution, we have our u value over here. So for this first piece, u squared or e to the x squared, I can write this as e2x over 2. Then this becomes e to the x. And then here, I really can drop the absolute value. This is always positive in this form or in that form. So this is going to become e2x plus 1 minus arctan of e to the x, add a plus c, and that's it. Okay, there you go. Good problem from UK. Sample problem number 20. Thanks everyone for watching. Have a good day.